I work at Khan Academy, which is based in Mountain View, California. We're making online education tools. And recently I got really excited about Reason, which is what I call JavaScript-flavored OCaml. And the purpose of this talk is just to kind of give a general overview of kind of what it is, what it looks like, and then hopefully we'll spend some time at the end talking about your questions. So, first I'm going to define some terms and then talk about what Reason looks like, what the status is, and then comparing it to Elm and Flow and other languages that you've heard of. So OCaml, how many here have written any OCaml before? Okay, good. So I've got a whole introduction about OCaml and I won't have to skip it. And then, so OCaml was invented in 1996, so it's 21 years old. Mostly kind of academic focused, although there are a couple of big companies that have based their whole stack on OCaml. It's been pretty fringe. There are a lot of PhD theses written about it, but not a lot of community, not nearly as much as other mainstream languages. Reason is mostly just a syntax, a new syntax for OCaml that is more accessible to people coming from JavaScript, from Java, from C-like languages. And there's also some initiatives in Reason to make better documentation, better build tools, but generally make it easier for new people to join. BuckleScript, I'll also mention, is a new backend for OCaml so you can take your OCaml and compile it to JavaScript. There has been a backend for OCaml to JavaScript, but BuckleScript produces actually very readable JavaScript. In many cases, JavaScript you would have written yourself by hand, and it's also very fast. So that BuckleScript is coming out of Bloomberg. All right, what does Reason look like? Here is some Reason code. This is actually React Reason code. They've got JSX built into the Reason syntax. And you can see there are types, there are functions, arrow functions, records, various things. So here are various things you can do with functions. We've got add x and y. That's how you declare kind of a normal function. Functions are curried in OCaml, similar to Haskell or Elm, where if you just give add the first argument, then it'll wait for the second argument. You can call add 3 with another integer, and it will then give you the sum of the two. They can also have labeled arguments. So we've got name and greeting in the greet function. And so those you supply with the label. If you've written any Objective-C or Swift, this will be familiar to you. And labeled arguments can actually be passed in any order. We've got types. And the types of functions or variables that you define are fully inferred. Almost. In most cases, they're completely inferred. So you don't have to write a bunch of type annotations, and it'll just figure everything out for you. But in many cases, you do want to write down the types. Here, I've got type x equals string. Type t, if you don't give it a definition, then it's kind of an abstract type. There are generics, so list is a generic. You pass it another type parameter, and you get a list of integers. We've got the option type, which is like the maybe type. So there's something or nothing. It's super useful. Records are kind of like objects in JavaScript, but there are some key differences. It's a bunch of things that you identify by attributes. And objects are like records, but they're a little bit slower, but they're more flexible. For example, here, I've got two different types of objects that both have a name. Person has a name, country has a name. And this function takes an object, any object that has a name on it, which is a string, and it'll be able to work with it. With records, this object will only accept a country won't accept person. So if you want row polymorphism, is what they call it, then use objects. But in a lot of cases, records are fine and they're super fast. We have pattern matching, which we have in Swift or Rust. If you're familiar with those, it's kind of like the case or switch case in JavaScript and Java, except it's a lot better. Here, the person record from before, I'm saying this first case, if the name of person, this is a value, so I'm switching over. If the name is PolyJS, return 1,000. If the age of that person is 10, return 100. Then the underscore means anything else, return 0. And that value then gets assigned to Z. Here's an example of using option type. So some name, we can switch over that. If it's something, and we just return context. If it's nothing, we return a default string. Reason has lists and arrays. Lists are linked lists, and they're immutable. They're really nice if you are just kind of mapping over everything or reducing. And the functional paradigm really favors linked lists and that way of doing things. But sometimes you want a mutable kind of more performant data structure. And so arrays are fixed length, but they have constant time access and update. So sometimes you're going to want to use arrays, but in most cases, lists are the best. OCaml and Reason also has mutability, which is kind of a pragmatic take, where in most cases you want immutability, you want kind of all of the solidity that gives you, all the guarantees it gives you, but sometimes you just want a mutable variable. And to do that, you have refs. So if you define a ref, you can update the value with colon equals, and you have to use the pound, the exclamation point accessor to get the value out. As I said before, arrays are also immutable, so sometimes you want that. And there are classes which you can define a mutable variable on a class and then update that. Modules. So a file is a module. And a module can contain types, it can contain values, so let bindings, and it can also contain other values, or other modules. So you can nest modules inside each other. So a file is a module, but it can also contain submodules. And this is just an example of defining a type that uses a type inside of a module and a value inside of a module. Functors in OCaml are different from functors in Haskell, if you're familiar with those. So this is different. But a functor is basically, it's a module that is parameterized over another module. So say we have a module type that knows how to add two things together. And here we have type T, which, again, we didn't specify. So it's abstract. And then this is a functor that takes something that adheres to the signature, and it will give you a module that has an add twice method that just calls the add twice on the arguments. And then we can say, I want to make a double adder with integers. So here type T is integer, and add is defined as x plus y, and then it'll give us an add twice method. Reason also has syntax extensions. So similar to Rust's procedural macros, it allows you to do compile time transformations over the abstract syntax tree. It's basically Babel plugins, but it's built into the language, first class. And having this is really nice because there are a lot of things coming from JavaScript. You want to be able to produce modules on the fly. You want to be able to kind of cut out some boilerplate, but the type system won't let you because modules have to be defined already. You can't loop over a list of things and create a module for each of those. But if you create a compiler plugin, that transforms the AST, then you'll be able to get that. And so we use this for things like automatically defining serializers for JSON. And this is a BuckleScript syntax extension where you do bs.raw, and you just pass in a string. This curly brace bar syntax means a multi-line string. And this will just kind of embed some JavaScript inside your Reason code if you need to jump out and do that. And one of the things that I've done with syntax extensions in Reason is implement letGuard. In Swift, it's really handy for basically an early return. In OCaml, there's no return statement. The value of a function is just the value of the last expression. And so if you wanted to do an early return, you often find yourself doing, say we've got this maybe name that is an optional name. And you have to switch on it to get the value out. And so if it's some x, then you do a bunch of stuff. And in the other case, you just want to return some default value. So here I made a syntax extension that allows you to say guard let, and then kind of the contents that you're matching on, and provide a default value here, and then you've got the whole rest of the block to do kind of the real work you want to do. So syntax extensions, super cool. What's the status of Reason? So Reason has we've got a chat room in Discord, and periodically people come in and say, I want to convert my company over to Reason. How do I do it? Or, can I gradually take this production app and start moving it over to Reason? And currently, I'd say wait 6 months. There's a lot of stuff that's up in the air. It's currently at the level of enthusiast developers that really want to be on the cutting edge and try out this cool new language. Definitely jump in. I wouldn't put it into production, although Facebook has put lots of it into production. So you can trust them if you want. The type system is rock solid. It's 20 years old, quite powerful. The syntax is still being finalized. There's a pull request open to move the function application syntax to be just like JavaScript. So curly braces, commas, to make it even more familiar to people coming from JavaScript. So, and that'll land probably in the next month or two. But there will be, an automatic upgrade script to move all your code over if you want to jump in now. Build tools are much better than they were 4 or 5 months ago. BuckleScript has a build tool included, and then the OCaml community have also come up with a new build tool because the kind of the historical state of things has been very fragmented. As far as package management, BuckleScript uses NPM. So for better or for worse, NPM isn't necessarily designed for a compiled language, and so there are some words there. And the current OCaml compiler is called OPAM, but it uses a global installation. So you can't have different versions of a library for different projects, and that sucks. Especially with a compiled language where one version of the library has a different type than the other one, and so nothing works. But OPAM is coming out with a new version here in the next little bit that uses kind of a node modules style where each project has its own installation route. As far as editor integration, OCaml has actually really cool editor tools. I'll demo here this. This is some of the React Reason code that I showed earlier. And if you mouse over something and the stars align, let me see. I'm going to switch over to VS Code. So the first thing you'll notice is these little type annotations above all of the top-level forms, where this plugin just asks OCaml, what's the inferred type, and shows it to you, which gives you the best of both worlds, right? You don't have to write out all the types yourself, but you still have the readability of seeing what everything is typed as. So that's super nice. And then mousing over any of these things, you get type hints on whatever anything is. You also have inline warnings, like it's telling me that this variable is not used, and inline errors. So the editor plugin situation, I'd recommend VS Code or Atom. It's pretty good. It can be a little flaky, like sometimes it just breaks and you don't know why, and then you have to reinstall everything. But it's super fun. Okay, documentation is really one of the sore points, where, again, OCaml, historically very academic. Most of their documentation is literally just the type signature and nothing else. And that is not super helpful. There are very few examples, either in the standard library or in kind of community projects. So that's something that we're really trying to work on. And writing blog posts and stuff explaining all these things. Standard library is also kind of funny because there are like 4. The OCaml standard library is so small that there are literally 4 different like standard library projects that have sprung up, and it's different camps. Like you come into some, like, oh, I want to use this markdown parser. Oh, it uses this standard library, and I'm using this other one. Too bad for me. So that's kind of weird. In Reason and BuckleScript, we're gonna bake everything into just the compiler itself, and hopefully fix this. But it'll be a little while in coming. Community libraries is also very early days as far as Reason libraries that will compile to JavaScript with BuckleScript. The ones that are out there are unstable, super early. So that'll also be a while in coming. So comparisons. That was kind of the quick overview of everything going on in Reason world. Compared to Elm, lots of people ask me, Reason versus Elm, what do you say? And Elm is awesome. It makes different trade-offs. With Elm using JavaScript, Elm kind of keeps JavaScript at arm's length, right? In order to talk to JavaScript at all, you kind of pass over this message passing, and then you receive it back. And that gives you a lot of safety, right? JavaScript isn't going to mess up your type system, but it can be pretty cumbersome. And as a result, the Elm community, like most of their code, they want to keep it in Elm and not use node modules, not use raw JavaScript, which is great if that's the way you want to run things. With Reason and BuckleScript, it's there are a lot more affordances for talking directly to JavaScript. Like I showed before, you can just drop some JavaScript in if you want to play fast and loose. And honestly, me coming to this language new, knowing lots of JavaScript, there have been lots of times where I'm like, I know I could work this out with the types and with immutability, but I really I want to get something on the screen so that I can start playing with it. And so I just break out into JavaScript, write some quick code, and then later I come back and I do it the right way. Elm also, the type system is less mature, which it works really well for a lot of people, so that's great. But one cool thing about Reason is that it does compile to native code. So native code or JavaScript, and there are cross compilers to Android and iOS that are also a little new right now. But there's a lot of promise there. And OCaml and Reason have a big emphasis on performance. So the compiler is super fast, and the output code is also quite fast. And that's all I've got for you. So I hope you have questions. So Jordan Walk, the creator of React, started Reason, and I was interning at Facebook, and he was showing me these things, and I was like, that's kind of cool. That was 2 years ago, and it's kind of gradually gotten more usable. And in the past couple of months, I've come back to it again, and I'm like, wow, I can actually start building things with it. I've always been interested in having a powerful type system and that kind of thing. So you can pretty easily write basically an an externs file, a type definition for the third-party library, and start using it. So that really helps with the current lack of community libraries written in Reason. You can just grab a node library, write some types for it, and then bring it over. And there's actually a really cool project that will, it's a Webpack plugin where you can just require a Reason file. It'll compile it. And it also handles flow type definitions. So it will automatically write kind of the interface into Reason based on if you have everything flow typed on the JavaScript side. Yeah.
So I want to go play around with Reason. How to install this thing. I think I saw it.
Yeah. Yeah. So creating. So I've written several blog posts about this. JaredForsyth.com. If you want to, so getting started with Reason and BuckleScript, and then I go kind of deep into JavaScript interrupt, and then writing, targeting the native, writing a CLI tool. So those are definitely what I would recommend. But basically, to get started with BuckleScript, you don't have to install like the OCaml system. You do have to install it if you want the nice editor integrations. But BuckleScript is actually just an NPM module that you put in packages.json. Other questions? Yeah? Yeah. I see it, I think Reason is really attractive to people who are writing JavaScript using Flow and are unsatisfied with JavaScript's runtime semantics. And Flow is also has a new type system. There are some things that it can't do, and you want real types in your code. I think it'll get a lot bigger. I think it's really promising, and I think people will start to use it to target React Native or native mobile, and also the web. I haven't, like I said, I don't recommend that other people use it in prod yet. I don't use it in prod yet. But I'm hoping, I don't know, maybe a year down the road. Yeah. Other questions? Thank you very much.